Hello, welcome back. In the last lesson, I showed you how to arrive at the formula for sine theta, and as I said, if you get confused after seeing the examples, leave them, stick to what your teachers have taught you, because I would rather you stick to the method you are comfortable with than try and learn a new method and get confused and lose your mark. I don't want you cursing me if you don't get 100%. My job is to help you get 100%. And if you're happy with the formula your teachers have taught you, please use that formula. Don't have to do this. Okay? Just in case someone wants to try a new method or maybe find a new way, I'm doing it. That's all. So don't worry. In case, oops. Now I need my calculator. That's what I'm looking for, because without a calculator, I can't work. Very good. Hello, by the way, my name is Susale Mohana. I have taught maths for a long time, to be precise, 50 years plus, one term exactly. And I'm trying to do these lessons just to help students revise what they have learned in school. Okay? Or from the, or people who are preparing for themselves without attending school. Some of you are trying to do it on your own, then from your textbooks and so on. Okay? Last time I gave you the formula, I didn't do any questions. So today I will do examples on solving trig equations. Of course, students in India will be asked to do a general solution, but in the UK syllabus, we don't have, I don't know about the American syllabus. If the general solution is there, you can use that, or minus 1 power n equations of a single angle. Later on, I'm going to use the same method for double angle and so on. Oh, let's not write it off a single angle because I might do the other equation. That's it. Let's take example 1. Solve for 0 to 360 degrees inclusive. Let's look at part A. Tan theta equal to minus 1.723. Of course, I should mention giving answers to the nearest 0.1 degree. Or exact answers, whatever it is, we shall see. So then what we do is, we have to look at the first job. So I'm using the tan formula. Go to your calculator. Please make sure the mode is in degrees, D, because later on we'll do with radians as well. I remember an exam where a student, in question 2, he had converted to radians because it was something else. Later on, throughout, he used radians, and he ended up losing quite a bit of number of accuracy marks because most of the questions were on degrees. Anyway, coming back to this, so I'll do tan inverse minus 1.723. Oh, let me make it 1.7061 because 723 is almost 60, that's why. It is minus 59.6. So your PV is minus 59.6. So the first job is find the PV. Then write the general formula. Theta equal to 180n minus 59.6. I want from 0 to 360, correct? So therefore, when you put values of n, you only consider those values that fall between 0 and 360. So if I put n as minus 0, look, n can be minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. If I put n as 0, it's going to be negative, of no use. If I put n as negative, the values are going to be negative, I don't need it. So I'll start, if you put n as 1, what do you get? Theta will be 180 minus 59.6. 180 minus 50 is 130. 130 minus 9 is 121. So 120.4. And it is within my range. Good. Let's put NS2. 360 minus 59 point. You don't even have to write this, but I am writing it for my own convenience. 360 minus 50 is 310. Minus 9 is 301. So 300.4. Yes. What happens when you put NS3? 540 minus 50 is more than 360. So I can't. So you only have, remember, 1 theta, 0 to 360, 2 solutions. So therefore answer is theta equal to 120.4, 300.4. After you find the answers, please list them. That way you're making sure you are within the range. Once you cross the range, stop looking for it. That was, like we go from preview is very nice. Only when you start seeing the actual questions, you get worried. Same way. So I'll take another example. I'll take a couple of examples to show you. Suppose I had question 2, part B. I'm saying cos of theta minus 20 degrees equal to 0.8193. Whenever you have an angle which is not just a theta or a 2 theta, any other than any angle theta, suppose you have 2 theta, suppose you had theta minus 20 as you have here, or theta plus 45, or 3 theta over 2, or 4/5 theta, anything. You always first write the general solution, keeping that as it is, meaning, I will show you in the example. You write the general solution and then make theta the subject. But if you account for the 20 in the PV, some answers will be correct, some answers will be wrong. So whenever you want to use this formula, always general formula first. General formula first, then simplify. Otherwise, some answers will be wrong, some answers will be right. Please bear that in mind. So therefore, I find PV as usual. So PV is, I'm interested in cos inverse point. Don't take 20, look, shift cos 0.8193 is 34.98 or approximately 35 degrees. Please don't say, so therefore theta minus 20 is 35, theta is 55, so PV is 55. I'm sorry, it doesn't work. Okay? It works, some of the answers work, some of the answers don't work. So I don't want to confuse you. So leave your PV as cos inverse. So I will put it here so that you understand. PV is just cos inverse 0.8193, approximately 35 degrees. This mentally is your x. So therefore, theta minus 20 equal to 360n plus PV, 360n minus PV. You have to consider both. If you consider only one, you get one set of values. So take the 20 now to the other side. So theta equal to 360n plus 55. Remember, it would have worked, but here it won't work. 360n minus 15. So you will get correct answers here, you will get wrong answers there. So you need to be careful. Now I want 0 to 360, put n as 0, I get 55, accepted, minus 15, reject it. Put n as 1, 360 plus 55 is 415, rejected, 360 minus 55 is 345, accepted. You have already crossed 360. No need to go further. You have already gone to negative. No need to go further. So you have your answer. Alright? 55 and 345. Do you understand the method? I hope it's quite clear. I'll take just one more example using sine now, because I've done cos and tan because I wanted to make you understand how to use the PV. Now let's look at the third example. Part C. Sine of 2 theta minus 40 degrees is equal to, plus 40 degrees equal to 0.8. No, yeah, 0.8. I want from 0 to 360. Later on, I'll take some examples. I still have plenty of time. Good. So, first job is find PV. This is where I want to show off a bit. For 0.8 is 4 over 5. The angle is 53.13. So, PV is 53.1. Check your calculator. Sin theta is 0.8. Sin is of 0.8 will be 53.1. I'm a genius, man. Or lady. Okay. And then, in sine only, you find SV. 180 minus 53.1. 180, 130, 127, 126.9. Only for sine, you find SV. So, rewrite the general formula first. Let's make it 70 degrees. Doesn't matter. So, 2 theta plus 70 equal to 360n plus PV 360n plus SV. Take 70 to the other side. 2 theta equal to 360n. 70 minus 50 is 20. 20 minus 3 is 17. So 16.9. 126 minus 70 is 56. 56.9. No, 56.1. So 360n. Is that correct? 126.9. I need to do. I can use a calculator, but I want to show off. So it is 70 minus 53.1. 10 minus 1 is 9. 9 minus 3 is 6. 6 minus 5 is 1. 16.9. That's correct. The other one is 126.9 minus 70.9. 6. 12 minus 56.9. 360 plus PV. 360 plus SV. That is now your 2 theta. But I want a theta. So theta will be 180n minus 8.45. 180n plus 28.45. Or 180n minus 8.5. 180n plus 28.5. Good. Now let's start putting the values of n. Can I rub this off so that you have seen more what I'm doing? So what happens when you put n as 0? Let me write the value here. Is 180n minus 8.5. 180n plus 28.5. Very good. So I can rub off all these. I want to show you how to list the values, find the values. I want 0 to 360, so put n as 0. That is negative, don't even bother writing, 28.5. Put n as 1. 180 minus 8 is 172, 171.5. 171.5. 180 plus 28 is 208.5. Put n as 2. 360 minus 8 is 352. So 351.5. and that is more than 360. Look, you've gone below 0, you've gone above 360, so these are your answers. So therefore, solution is x equal to or theta equal to 28.5, 171.5, 208.5 and 351.5. See the advantage of this method when compared to looking at the quadrant, going over a circle is, there you have to decide how many times am I supposed to go, what happens if it goes second quadrant, do I multiply by 2, do I subtract this, we don't have to bother, you just have a formula, make theta the subject, the only thing you remember is, first write the general formula, then make theta the subject, then keep on putting values to get the answer. I find this very convenient, but as I said, you have a choice of what you want to do. Very good. Let me take one more example. Later on in the next lesson, I'll show you how to use this using identities as well. I don't think I'll have time to do both. Let me take another example which is typical. Example 4, I think. Suppose I had sine square 2 theta equal to half. Typical error among students is this. I have seen this, so sine 2 theta equal to 1 over root. If the question said sine 2 theta equal to 1 over root 2, then that root 2 is positive. But if this question, you are taking the square root, whenever you take the square root, use plus minus. So it is plus minus 1 over root 2. A good number of students, when I used to mark their prep or their tests, this was a very common error. Even some of the further math students, be careful. So therefore, I can say sine 2 theta equal to 1 over root 2, sine 2 theta equal to minus 1 over root 2. You can work them separately. PV is 45. Let me make it 1 over 4. You know why? Because I don't want decimals. 1 over 2. So that's a 2. That's a 2. Right? So PV is 30. If you look at the calculator, PV is minus 30. It is a sine. So SV is 150. SV is, that's good. 180 minus 30, which is 210. You need to be, it's not 180 minus 30 there. It is 180 minus 30. So therefore, 2 theta equal to 360n plus 30, 360n plus 150, 360n minus 30, 360n plus 210. You got 4 formulas. So what is theta? 180n. Let me write theta here so that I have space. A simple question, one square root and double angle makes so much work. So theta is equal to 180n plus 15, 180n plus 75. I will put the negative in the end. 180n plus 210 and 180n. 180n plus 105. 105. 180n minus 15. Let's say for this question, I want find from minus 180 common answer generally. Either they will say 0 to minus 90 to 90, minus 180 to 180 or 0 to 360. Rarely they ask you from minus 360 to 360. So got that, and I've changed the question. I want now answers from minus 180 to 180. You should start with minus 1, but start with minus 2, see if it works. Minus 360 plus, below minus 180. Minus 360 plus, below minus 180. Minus 360 plus, below, so there's no need to do minus 2. put n as minus 1. What do I get? Theta equal to minus 180 plus 15 is minus 165. Minus 180 plus 75 is minus 105. Minus 180 plus 105 minus 75. Minus 180 minus 15 is minus 195. I don't need it. That means I have crossed minus 180. So we go further. Put n as 0. Theta will be 15, 75, 105, and then minus 15 is acceptable. That's perfectly alright. Put n as 1. 180 plus 15 is out. 180 plus 75 is out. 180 plus 105 is out. 180 minus 15 is 165. So you got 1, 2, 3, 4, 5, 6, 7, 8. 1 theta, 360 degrees, 4 answers. 2 thetas, 360 degrees, 8 answers. Thus, mentally you check that you got the right number. Always put them in ascending order. The smallest angle is minus 165. The next angle is minus 105. And then the next angle is minus 75. Then you have a minus 15. Then you have a 15. Then you have a 75. Then you have a 105. Then you have a 165. 1, 2, 3, 4, 5, 6. Always cross check. 1, 2, 3, 4, 5, 6, 7, 8. I have written 8 answers. There you are. So I have taken you through how to apply this formula. As I said, you don't have to copy them. I might put some examples to show you. Otherwise, keep the notes which are the formula and look at these examples. Make up your own from textbooks, or look at a textbook. There are so many questions. Pick them, do it. Use your method if you're comfortable with. If you want to use this method, use this method. Cross-check your answer with the answer in the textbook. Okay? Have a nice day. I'll see you next time. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.